So hello and welcome back. So we have an example here related to the half-life of carbon-14. So it seems that carbon-14 is an element which loses basically half of its mass every 5,730 years. So the mass of a sample of carbon-14 can be modeled by a function m, which depends on its age, t in years. So we measure that the initial mass of a sample of carbon-14 is 741 grams. So the initial mass is 741 grams as we measured it. Now write a function that models the mass of the carbon-14 sample remaining t years since the initial measurement. So basically you could solve this problem in two different ways. First, you could use the table that we have been talking about, that we have been using. There is another way as well. So you know that the general form of course you know that this whole situation fits into a exponential function. So then an exponential function is of the form, let's use the notation here, so m of t is equal to a times r raised to the power t. So this is the initial value of your function when your input is equal to 0. When your input is 0, this becomes 1, and then 1 multiplied by a becomes simply a. So then this a becomes the initial value of your function when the graph of the function goes through the y-axis. And then your r is the common ratio. So your common ratio is basically with t, for example, going from 2 to 3. So from 2 years to 3 years, for t is equal to 2, you have some sort of output. For t is equal to 3, you have some sort of output. And if you multiply the output related to year 2 by some fixed value, you will get the output related to year 3. Again, if you multiply the output related to year 3, if you multiply it by a fixed value, by the same value, essentially, you will get the output for year 4. And this keeps happening. So this fixed value is being multiplied by every output to generate the same output, to generate the next output, and so on and so forth. So that's basically your function here. Now, the initial value of this function when t is equal to 0, it corresponds basically to this initial mass of the sample. So you can write this as m of t is equal to 741 grams. So 741 grams. So remember that the output of this function, whatever that might be, is going to be in grams, because the initial mass is written in grams. And then what happens here is that this element loses exactly half of its mass every so many years. So losing half of your mass means that you're decreasing the amount of mass by half. So you simply multiply this by half, and so this can represent basically the amount remaining after half is taken away, or it could also be simply simply the amount of, or it could simply represent half of 741. You can interpret it in any way you want, and either way it works for us. And then it happens every 5,730 years. So if I write this as, if I write my t here just as t, so then every year, because t here is in years, I suppose, t here is in years, so then every year, so for example from year 1 going to year 2, in year 1 this is half raised to the first power. So in year 1 half of the whole mass is being reduced. In year 2 it becomes basically 1/2 raised to the second power. So it is basically 741 times 1/2 times 1/2. So that basically means that 1/4 of the mass is reduced, and so on and so forth. It becomes 1/4, 1/8, 1/16, 1/32, and so on and so forth. But I don't want this to happen every year. I want this to happen every 5,730 years. So every 5,730 years means that I divide this t by 5,730, and then unless this t becomes 5,730, this cycle cannot happen once. So when this t becomes 5,730, this whole fraction becomes 5,730 divided by 5,730, so that's basically 1. And then you have half raised to the first power. In another 5,730 years, this whole fraction becomes 2. So then this cycle can happen in basically twice and thrice and so on and so forth. And so that's basically your function. This is basically what you were looking for. And that is your function. Now 741, okay. Now, in case you did not understand this, again, we have the same problem, the same example here. You can have a table. And then here you have t in years, and here you have m of t. This is the mass of the carbon-14 element, the carbon-14 in grams. Now, in year 0, basically when we measured, it was 741 grams. And I know that in 5,730 years, it loses half of its mass. So in 5,730 years, I have to multiply this by 1/2. And again, the same thing keeps happening here. So it's basically after another 5,730 years, so basically 5,730 times 2. Again, this is halved, or this is basically half of this is lost. So it becomes 741 times 1/2 times 1/2. And this whole thing keeps happening and happening and happening up to the whole eternity. So what that means is that you can simply write your function based on this table. Again, it's the same story. So you have so basically what we can do here, let me see if I can derive it based on this table. So based on this table, what happens is that what happens is that so you need to find some way. So here basically you have a half raised to the so basically what happens here is that again you have the same, basically the same general form of an exponential function, which is m of t is equal to a times r raised to the power t. So again, m of t is equal to a, which is your initial value of your function, which is let me erase this. I was trying to figure out some way to explain this in another way, but it's simply not necessary. So basically the initial value of your function is when your input is equal to 0, and that's when the graph of the function goes through the y-axis. So that's basically 741 times r, which is basically, you could take any two input output sets, for example these two, and between these two you can see that this input has been, this output has been multiplied by 1/2 to get this whole output, to get this whole new output. Again, this output here has been multiplied by 1/2 to get this whole new output. So you can see that your common ratio is half. And of course, normally you would write this raised to the power t if this was happening every cycle of your input variable changing. For example, every cycle between 0 to 1, 1 to 2, to 3, to 4, to 5. Every time if it was happening, you would simply write a t here. But it took the carbon 14 5,730 years to go through this cycle of getting halved. So you should do the same thing here as well. So you divide this, you divide this t by 5,730 years, and now it takes this, for this cycle to happen once, t has to be as big as 5,730 exactly. So then it becomes 5,730 divided by 5,730. So this whole fraction becomes 1. And then this becomes half raised to the first power, which is basically half. And so when that's half, that basically means that one factor of half has been multiplied by 741. That means 741 has been reduced to half. And so then it has gone through this one cycle here. And again, the same thing happens here after another 5,730 years, over and over again. So again, that is the same function that we found here, 741 times 1/2 raised to the power t by 5,730, and that's basically your function here. So that's that. So I'll see you in the next video. Thank you.